A high-speed train is about to cross the Yangtze River. But it won't cross on a bridge. It won't slow down for a ferry. It will go underneath the river. Deep below the water, engineers are building a 14.25-kilometer railway tunnel connecting Chongming in Shanghai with Taicang in Jiangsu. And when the railway eventually opens, trains will be designed to travel through this section at speeds of up to 350 kilometers per hour. The idea sounds simple. Dig a tunnel. Put a railway inside it. Let the trains pass through. But the Yangtze isn't an ordinary place to dig. At its deepest point, the tunnel runs about 89 meters below the river's surface. That's roughly the height of a 30-story building. And above the construction site, the river doesn't stop. Ships continue moving. The water keeps flowing. The riverbed remains under pressure. And underneath all of it, a machine weighing about 4,000 tons is slowly cutting its way forward. Its name is Lingheng. The machine is around 148 meters long, with a cutter head about 15.4 meters in diameter. But the size of the machine isn't the most difficult part. The real challenge is keeping everything under control while the machine moves through the ground. The soil can change. The water pressure changes with depth. And the tunnel has to remain precisely aligned from one end to the other. Because this isn't just a hole through the riverbed. It's going to become part of a high-speed railway. And at 350 kilometers per hour, precision matters. So how do you actually dig something this large beneath one of the world's major rivers? The answer begins with a machine that doesn't simply dig. It builds the tunnel as it moves. And once you understand how that works, the scale of this project becomes much easier to appreciate. The hardest part wasn't simply removing the soil. It was controlling what happened around the excavation. Lingheng uses a large cutter head at the front of the machine to break apart the ground. But behind that cutter head, the machine is doing much more than digging. The excavated material has to be removed. Pressure at the cutting face has to be carefully controlled. And the empty space created behind the cutter head has to be supported before the surrounding ground can move into it. This is why a modern tunnel boring machine is better understood as a moving underground factory. Cuts. It removes material. It supports the excavation. And it creates the permanent tunnel structure as it advances. Behind the cutting section, prefabricated concrete segments are assembled into rings. Ring by ring, those segments form the tunnel lining. The process repeats as the machine moves forward. Remove, build, move, then repeat. But beneath the Yangtze there is another problem. Water. At the deepest point, the tunnel sits about 89 meters below the river's surface. At that depth, the water alone adds roughly 9 atmospheres of hydrostatic pressure. That pressure doesn't come from one direction. It acts against the tunnel system from the surrounding environment. So the excavation has to remain carefully controlled. Too little pressure at the cutting face can allow water and soil to move inward. Too much can disturb the surrounding ground. The geology also changes along the route. The machine encounters different layers of sediment and soil, including water-rich formations and harder material. That means the tunneling system has to adapt as conditions change. And the engineers weren't working in an empty environment. The route passes beneath an active waterway. Ships continue to use the river above. The project also had environmental considerations because the route passes beneath an aquatic habitat. Excavated material and turbid water therefore had to be managed, rather than simply released into the river. A closed slurry system was used to collect and recycle excavated material and water, while pressure at the cutting face was carefully controlled. From the surface, almost none of this is visible. The river continues to look like a river. But underneath it, a 4,000-ton machine is slowly creating a railway corridor. And it has to stay on course. For more than 11 kilometers. Without the luxury of stopping whenever the conditions become difficult. That's where precision becomes just as important as power. A tunnel for ordinary transportation can tolerate certain imperfections. A high-speed railway has much less room for them. A train traveling at 350 kilometers per hour covers nearly 97 meters every second. So the railway alignment has to be extremely precise. The tunnel cannot simply wander through the ground. Its geometry, structure, and track system all have to work together. Project engineers have described millimeter-level control as an important requirement for maintaining the tunnel's alignment. And that precision has to be maintained while the machine is moving through a changing underground environment. This is one reason the tunneling process matters so much. The machine isn't creating an empty cavity that engineers will figure out later. The permanent lining is being created as the excavation advances. The concrete rings become the structure that separates the future railway from the surrounding ground and groundwater. Waterproofing is built into that system. The tunnel also needs drainage and monitoring systems to deal with the underground environment over its operating life. But the most demanding part of the construction was the length of the underwater drive. Linghang completed an 11.325-kilometer continuous underwater drive, a record for a shield machine of this class. The machine began its tunneling journey from Chongming in 2024. It eventually reached the Taicang side in March 2026 after months of underground work. Then came the breakthrough. On July 30, 2026, Linghang broke through the underwater section. For the engineers, that was a major milestone. But it is important to understand what the breakthrough actually means. It does not mean the railway is already open. The boring operation has reached its major milestone. But the full tunnel still needs additional construction and railway systems before passenger service can begin. The complete tunnel is 14.25 kilometers long, and project plans call for construction to be completed by the end of 2026. After that, the tunnel has to become something much more complicated than a concrete passage. It has to become a railway. That means track, power, signaling, communications, train control, ventilation, drainage, fire protection, emergency systems, and continuous monitoring. Every one of those systems has to function inside a sealed underground environment. And unlike a normal surface railway, there is no open landscape around the train. If something happens inside the tunnel, emergency planning has to account for the fact that the passengers are surrounded by concrete, earth, and water. That is why finishing the excavation is only one milestone. The real transformation happens afterward. A hole beneath the river becomes infrastructure. And infrastructure becomes a railway. When the construction is finally complete, passengers won't see most of the engineering that made the journey possible. They'll see a train. They'll enter a station. They'll sit down. And the train will leave. At some point the landscape will disappear. The train will enter the tunnel beneath the Yangtze. And the river will continue flowing above it. That simplicity is the whole point. The tunnel is being built as part of the Shanghai-Nanjing-Hefei high-speed railway corridor, connecting Chongming with a wider high-speed rail network. For Chongming, the connection is particularly important. The island has not had direct high-speed railway access. The new railway is expected to connect Chongming with Taicang and Shanghai's Baoshan area, with a planned journey from Chongming to Baoshan taking around 17 minutes once the line enters service. So the tunnel isn't being built simply to break an engineering record. It's solving a geographical problem. The Yangtze creates a physical barrier between places that increasingly need to function as one connected region. A bridge could cross the river. But a bridge isn't always the best solution. The river is heavily used for navigation. The surrounding environment is complicated. And the railway needs a carefully controlled route. So engineers went underneath. That decision created an entirely different set of problems. Water pressure, geology, alignment, waterproofing, environmental protection, high-speed train requirements, and the challenge of building and maintaining a railway in an environment that humans were never meant to occupy. Yet when the project is finished, None of that will be obvious. A passenger won't see the 15.4-meter cutterhead. They won't see the 4,000-ton machine. They won't see the concrete rings being assembled underground. They won't feel the pressure outside the tunnel. They may not even think about the river above them. They'll simply be traveling. And that's what makes major infrastructure so strange. The more successful it becomes, the less visible the engineering is. The Yangtze will still flow. Ships will still move across its surface. The cities on both sides will continue growing. But underneath the river, a high-speed railway will connect them. Not over the Yangtze. Not around it. Under it. And when the first passengers eventually travel through that tunnel, they'll experience something that feels completely ordinary. Train ride. But beneath their feet will be one of the most technically demanding railway crossings China has built. 14.25 kilometers of railway beneath the Yangtze River. And perhaps the greatest achievement won't be that engineers managed to build it. It will be that, once it's working, most people won't even think about what's underneath them.